Thank you, folks, for coming in. I'm going to be talking about quick and dirty GUI applications and why we should make them. My name is Saif. I'm actually not a programmer. I'm a doctor. I have interest in computing, and I'm one of the executive body members of some organization called Chaos UK, which stands for Computer Assisted Orthopedic Surgeons of UK. I do some hobby 3D programming. Also, I'm interested in tissue engineering, and my talk combines programming with all of these things as well. So I'm just going to go through a few things. I'm going to talk about a bit of a context, brief insight into why I'm doing, what my goals are, something about tissue engineering, which some of you may be aware of, or some of you may be a new thing. I'll be talking about something called GUIDeFATE, which and describing how it works. It's a little application, a little module that allows you to generate a GUI interface. I'll be giving you examples, and the examples are designed to follow through what led me to what my goals are in the tissue engineering context. Then we'll talk about reflection. We'll talk about, does it all make sense? Most programmers are working the back end. They don't work with an interface which is for general public consumption. I work with doctors and scientists who may not all be programmers. But there is a certain, doing a GUI in Perl is difficult, at least difficult for me. And the question is whether the effort required to generate can adequately justify the rewards that I would get from it. Then I'll go on a bit of a soapbox and put the world to rights, as it were, and what I think is why it's all going horribly wrong. Then we'll have a conclusion about what it's all about. So first of all, context. So tissue engineering is a way of generating new tissue. Your body, your organs, and your tissues are made of cells which are supported by a scaffold, which is some collagen or hyaluronic acid or other molecules. So you can take a sponge of plastic and put chondrocytes on it, which are chondrocytes are cartilage cells, and put them on the back of a nude mouse. So this nude mouse has not got an immune system, so it will not reject human cells put on it. Yeah? So you take an object the shape of a sponge, the shape of an ear, put it with human chondrocytes, put it in the mouse, and that mouse will nourish that construct until a living cartilage ear develops on its own back. Yeah? So this was an experiment done by Professor Vacanti. He used to say once he made this mouse, he could never catch him because he'd always hear him before he entered the lab. So, but things have moved on a bit. We've tried to combine it with 3D printing. We can 3D print any shape you want, and this is a modern 3D printer which is designed to print in gel, and uses XY coordinates to generate a shape which you can populate with seeds and form something the shape of a heart or a kidney with cells in it. Currently, actually, we only are able to use one cell type, and most organs have multiple cells on them. Essentially, all these tissues also need a perfusion system as well, but that's a different story. So it isn't all that simple, you might think. So when you take a bit of an organ and chop it up to bits and then digest it, removing the collagen matrix, you liberate the cells, but these are a mixture of cells. I separate those cells and culture them separately, expand them, and then reconstitute them with some kind of jelly, some kind of collagen, and then reassemble them into an organ. That might work, as hasn't been done yet, but that's what our goal is. The goal is not just to create a shape of an organ, but to distribute the cells in that organ in geographically distinct areas. So the heart cells go in the heart location, the leg cells go in the leg locations, the brain cells go in the brain location. Those sort of structure to put it simply. So these cells have to be sorted out somehow or the other. And these are multiple steps with multiple points of failure. So one thing you can do, there is a device called the Fluorescence Assisted Cell Sorter, the fax machine. And what it does is you label cells with a dye. So your dye picks up, say, chondrocytes, cartilage cells, or endothelial cells. And you can put them through an inkjet printer nozzle type thing, a piezo transducer, which propels one cell at a time past the detector. And when that detector detects a cell, that signal is amplified and passed to a little deflector plate. And that plate is charged and takes a charged particle, because the cells are pre-charged on one side with positive charge, and they will move towards the negative, the cathode, and be sorted out. So you have a way of taking a mixture of cells and sorting them out and keeping them alive still. You could do this on its side in theory, and this is what I'm trying to develop. Yeah. What I'm trying to develop is something. Oops, sorry. Something more like a CRT, cathode ray tube. You propel the cells horizontally, and then use two plates to deflect them in 2 dimensions, and therefore ballistically launch the cells onto a surface. And therefore you have your pattern. You've created a pattern far away, which represents the distribution of the cells where you want them, in the geographic location you want them to, and then create them layer by layer by layer as time goes on. And that's the goal of my project. And difficulty is that these things require a computer, a program, and an interface that my colleagues will like to interact with. Not necessarily a command line tool with parameters that I pass them with various things, which are not that intuitive. So we fail before we have a brilliant idea, or maybe not so brilliant, but an idea, but we can't deliver that idea because we haven't got an interface that my colleagues can use. So the first thing to do is to create an interface that non-programmers will be able to use it without having to refer to a manual, with entering all the complex parameters, and all the other things, the abstract algorithmic transformations, the motion simulation, the we can sort out later. Well, the trouble is we have sorted the rust out. We've left the most important bit to the last, and that object dies there and then. So, the thing about 3D development, visualization is key. You have to be able to visualize what your target is, and you have to be able to see that you've achieved the target you want to achieve. So I need to make this fit into the paradigms that people understand. A window application, or an application on a desktop that they, and it needs to be, the back end may be complicated, and that interface has to interact with a different back end. It needs to be able to do core system actions, the system, because it needs to interact with the printer through a USB interface or whatever it is. It might need to do all these things. I need to be able to script it. I need to be able to give a script to say, after this is done, you do this step, and then you do that step, and then you do that step, or maybe do something several times. And then, of course, I need to control this external device, a device which is dumb from this intelligent front end. And all this could be done, I suppose, from a web interface, and have a little web server on my little device and do it all. But to me, I'm trying to reduce the number of components and reduce lag, reduce the need for a network, in effect. The trouble is, to do all these things, you need to know a lot of things. And these are not my areas of expertise, but I shall try. So basically, in order to do this development, I tried to generate a graphical interface for my applications. This is it's interesting that the logo for PerlCon Riga is this cat. A cat that's trying to look like a camel, I think, and it's clear that on which side of the Perl 6 Perl 5 divide that cat's after, anyway. But So there are modules for GUI applications, and there are several, and they're all outdated. Not many have been developed recently, as far as I can see. WX is the way when you look for GUI and get WX is what I come across. It's not easily installable in versions of Perl after 5.16. Qt 5 needs Perl to install it, but doesn't provide a Perl API. Yeah. Qt 4 does, and that was an old system that is the CPAN version of Qt 4 does not work. You have to get the KDE libraries from their own. TK works. It's reliable. It's long-lasting. It apparently looks ugly. It also has several primitive backend functions which make it difficult to do performance. One of the most embarrassing commentary on getting a GUI working on Perl was to use inline Python. I thought that's sort of completely. I mean, I would say that is a very regressive step from my perspective. And secondly, information on using Perl applications for GUI are getting less and less frequent these days. And there are toolkits for other things, WX, and each of them work. The difficulty I've had is that each system computer I try, whether I have a Windows machine or a Raspberry Pi or my laptop or my desktop, they all seem to have different difficulties in installing these applications. So I need to be able to have an application that runs on multiple platforms, on multiple backends. Otherwise, we are going to be using the universal backend, which is a browser window. So there are too many toolkits, too many paradigms to interact with GUI. There are too many widget types, yeah? Too many options. And I can't guarantee it'll work in all platforms, yeah? And this is a difficulty. We laud the diversity of the platforms that we have access to, but the diversity makes it sometimes it's easier to avoid this desktop altogether. I don't want to try a GUI. I want to try something else. Yeah, I'll go with a command line interface or something else. So back to the drawing board. Now it's easy to draw a GUI. I can take a pencil and paper and draw an interface. I could put it's got a little title bar there. It's got a menu bar. I've got labels, buttons, windows. I need to convert this into a GUI somehow or the other, and actually I can draw that on a text editor. I can take a text editor and draw that GUI. Yeah, so that GUI has is written in monospace font. It's got a little title. It's got what looks like buttons, what looks like text windows, and possibly an image box there, and some numbers that might appear, and that's easy to do in a text editor. So I can take that text, and Perl is good at parsing textual data. You can take that data and find the widgets that you've drawn through your text editor, and you should be able to generate a GUI from that. You can see from the text editor those buttons are in coordinate locations that you can actually transform into coordinates for a widget. So this is the design of the world's simplest GUI designer. Yeah, there are no tools, nothing external you have to learn. There are several toolkits it works with. It works with WX, TK, works with GTK, Qt 4. It even generates a web page, and it will even generate, if you want, a web application with the same interface from that design. So the idea is that this whole objective is to get an interface that is visual. The development is visual, and to reduce the complexity, we'll just have a handful of widgets. We don't have to have every single widget on the shelf. There's still a lot to be done, obviously, and there's plenty of bugs, and I'm not a professional, so I'm not the best for doing these things. But this is how this object works. GUIDeFATE module links to a backend module. It takes the textual representation and extracts from it the widgets that you can find using simple regular expressions, and it extracts the widgets that it can do that. It inserts those widgets into the frame object it created, and then returns that frame object, and that's the only object you return. And that frame object gives you all the things you need to do to interact with all the widgets that you've got there. And there are only a few widgets, few interactions you can have. You can set a widget, you can get a widget's value, and you can create one. So this and it is invoked simply. Yeah, you invoke it by using GUIDeFATE, pass a textual representation, choose the backend you're going to use, and there is an assist function. It can give you some assistance on how to use that as well. And then all you do is, some of the modules return the frame, some require you to have a function that returns a frame. So you can use this kind of if the function exists, then you use that to get the frame, otherwise you use the frame object that's returned. And then all GUIs have a main loop. A main loop is a loop that you're constantly looking for the user interaction. So here's a textual representation. It's a calculator, and it looks like a calculator over there, sort of, I think. And then you can generate the same with multiple backends: TK, GTK, cute. This one's cute, and this one's WX. Yeah. So all these backends look roughly similar from the same backend. And all that's being changed in the code is 3 or 4 letters. It's choosing the backend of it, and then to go from one to the other. So the convert function looks through all these things and says, look, I found a button with the label draw, and that when you click that button, it'll call a function button 0. If you have a button labeled logs, it'll call button 1. It sequentially identifies each widget, adds it to the frame, and allocates a callback function for that button. And you can avoid that concept. If you've done it already, you don't need to run that every time. You can have a quiet output, or you can auto-generate. You can auto-generate the script that contains all these subroutines with the labels attached to them and commentary attached to them as well, so that you can cut and paste them into your own code. So I'll give you some examples, and I just thought because the last cat was looking like a camel, I put one with a butterfly in. Sadly, my program doesn't work with Perl 6, I don't think anyway. But to go through these examples, I'm just going to get out of my browser session, and I'm going to call my launcher, which I've called an executioner, because it executes programs. So now remember what we wanted to do. We wanted to have an interactive interface with users, something that you will recognize. Yeah. So we saw the calculator earlier, and I can just put, calculate and add 68 equals, and it'll work like a calculator. If you want to see the code, I'll go through that code with you. But it is essentially very, very. It's a simple interaction with buttons and an input box. I also need some graphical input. So here's a little mini game. Rock, paper, lizard, scissors, lizard, pork. I don't know if you watch Big Bang Theory or other things, but this is an extension of the old rock, paper, scissors game, which includes Spock as well, but and lizard. So you can just choose a button that you want to say, I'm paper, and he was rock, and cover. So basically, I've been able to update that image, frame object, and update the text to say what the result would be, and I can. And the lizard's poison Spock. So all of these applications take less than a couple of 100 lines of code. They're very, very simple applications. Then we said we wanted to be able to have a complex backend, a usable interface for a complex backend. And one complex backend might be the GNU plot application. It's a complex application with lots and lots of functions. What about it's simple enough to have a text area and a drawing image. So this generates an image. This plot function generates an image, and I display that image. Very simple. So I can take a. I've got examples already coded in here. So I can take a complex torus. So this is I got it from the GNU plot website as a complex application. That code is passed onto that GNU plot backend, and the GNU plot generates the output, and I present the output to you. So the issue is this: I can make minor modifications to any of this code, and then I'll have changes in my output until I fine-tune it to what I need to do. So here's another one. Then we said we wanted to do complex back-end. We want to interact with our system, system tools. And one application that has gone or is going out of Ubuntu, which I use, is a last Perl desktop application that comes in by default in Ubuntu. There are lots of Perl back-end applications, but the last desktop application is Screenshot, or what's called Shutter. But this Perl is an easy way of using Imager. You can do a screenshot application, and this is, you can make it supersized. You can make it more than what a screenshot application does. So this screenshot application takes every single surface it detects on that window. So I can go through all the other. It captures not just that image, but all the other surfaces that are available. I can screenshot those. I can save those screenshots. I can edit them in GIMP. I can call another external function. I can take multiple screenshots. So I can take a screenshot every 5 seconds. And that will allow me to make a movie of whatever I'm doing. So those things, so here you have taken a simple function and you've extended that using a few lines of code. Then another thing I wanted to do was script my application. So I made simple logo. Simple stands for Simple Integrated Modular Programming Language Experiment. I have to make some kind of acronym that goes with that. But essentially the idea is this, that I can script a language like logo, like pen up, right, forward 12, pen down. I can use random words. I can use mathematical equations in there. So, and then I can generate a logo. So I can, for instance, generate a star. It's for a simple bit of code. Yeah. So I can repeat for the number of points. I can define variables and lengths. Repeat points times 2, because every point has 2 lines going to it, and then draw a star with that. Or I can do multiple random things, like generate multiple flowers of different shapes and sizes. But anyway, so here is a way of I can create a script in a language that I want of specific to my use case, and I can then display the output in the same interface. So basically, what it does do is brings to me the results of my scripting immediately. And it is more difficult to do in a command line application, and more difficult to do interactively in a command line application, or another thing. And one of the things I want to do is obviously do a robotic application. So I want to be able to control devices externally. Now I haven't connected anything over here, but I can I don't know. What I do is it's got a picture of me now. Essentially, what the objective is that I have a method of moving my server where I want it to go, and it sends a signal to my server, which I capture with a webcam attached to that. Unfortunately, the webcam in this laptop is pointing towards me, so if I capture, it'll just capture me, I think. So it doesn't do anything very exciting. The idea is that I've created a link. I want to make sure that when I make my server go clockwise or counterclockwise, that it's actually doing the same thing. And then later on, I want to be able to send the signals the motor not be able to see it, but actually be able to get a visual representation of where my motors are in these directions. So these are all fairly simple to do, and I can go through any code if you want me to, but I'll do that. Leave that for, oh dear, I'll leave that for, oh, it's all going to be wrong. Okay, so yeah, I can go over that later. But the whole objective is that there are lots of reasons for us to make GUI applications. Lots of little things that we do, which I'm going to have to, sorry, have to go to them. Just get out of here for a minute. And sorry. Go to where I need to go. So sorry. I accidentally closed it and I'm suffering. Sorry. Okay, so here are the little examples of these things. The actual for each of those applications, and you can see hopefully that the match the image box has the name of the image that I want to you insert into that box. I can choose various images. The box I mean, obviously I've colored them in, but obviously it won't be colored in later. But you can do complex things like a new plot. Sorry. There is one for the logo so basically the menu is just defined this way. The menu there, that application has a menu to allow me to do all these things over there, which doesn't appear on file image. And that file, image, and example menu is there. And each of those things call a callback function when you activate them. And this is the servo motor controller textual representation. So you can see that it's quite relatively easy. Even the executioner is written in this language, and I can just, and I don't know if you remember a version of Linux called Damn Small Linux. Have you heard? Do you remember that? That was when I was little, before many of you were born. But essentially, the idea was that you'd have a little panel which have multiple buttons on it, and that was your launcher for your various applications. And you can even change a couple of lines and produce a web interface for that. So let me just see if I can do that. I'll just see if I can do that for you, give you a demo of that. So this allows me to, this execution allows me to drop down box, and I can choose whatever interfaces are available, and I can try just try, I don't know, a calculator. It's going to be an easy one, hopefully. So it opens a browser. It does two things. It starts a server, which is listen to port 8085, yeah, and it also sends a textual representation of the transformation of a browser window in HTML to the browser. So the browser interacts with that with the server, which is listening on that port, and I can put down one. There's a bit of a lag, as you can see, but and it'll hopefully work for you. Yeah. So here you've created a web application without knowing too much about modulists or anything like that at all. This uses a much more simple backend. So let's get back to the presentation. So, and you can duct tape various other things. You can duct tape, it should be duct tape, shouldn't it? It shouldn't be duct tape. Anyway, I don't know. But essentially here is an application that takes two websites, the plantslist.org. You can, plantslist.org contains a list of every plant that's been classified by scientists. And Wikipedia has got loads of pictures. So I can look for pictures for any, if I look for an asparagus, I can look up all the asparagus files. It generates the family and the genus. And the family and genus I put it into Wikipedia and see if there's any images of that. So I can duct tape 2 different websites, present them on a desktop for me, and I can gradually accumulate a little local database of all these things. And it is transformative, yeah. Using a GUI makes everything different, everything better. It means that you have an instant interact. You feel you're interacting with a tool, and you can make legacy console applications interact with modern interface. And the thing about it is, the web interface is what we've all resorted to nowadays with things, and it is inappropriate for all scenarios to have a server backend to interact with always. Does seem to be a bit of overkill, and also narrows your scope. A niche that you leave behind is a niche that you lose. Yeah. So what happens is we become progressively more and more less capable. So now for my soapbox, I'll talk about, just to bore you further. Let's say a famous person says the goal of Perl is to make easy things easy and hard things possible. He also said that the power of programming language is not what it lets you do, but what it lets you do easily. So that technically hard things should be easy as well, and that's what we should. That should be what our goal is. You see. So when I started programming, long time ago, I had a ZX Spectrum. We programmed in assembly in Z8TA, or with a pencil and paper. I didn't do very much more after that until I picked up a second-hand book about Perl, and I don't have the capacity to learn any other language in my brain. I don't have that. It's not possible for me to do anything else. The Spectrum program for a Spectrum is going to be a fool's errand. Yeah, I'm not going to be able to use any of those applications. But Perl is different. Perl is ubiquitous, but it's invisible. And why is it? We know all about this Perl superpowers, yeah, all these functions that it can do. But because Perl serves a huge number of people invisibly. It does it through the back end. It's never presented as an application in the front end. And because it's robust, because it just works in the back end, nobody sees it. And if it's invisible, it will vanish. Yeah? And no one will notice if it vanishes. And that's the whole purpose. That if you have and it's possible to make complex GUI applications in Perl. This is a slicer, which is a 3D rendering software, which is written in Perl. This was a bubble something or the other game that was written in Perl, but not many visible nowadays. As I said, ultimately what we want to do is be able to interact with the user with multiple ways, to use all our senses, our ears, your eyes, your ability to do a 3D representation. And it needs to be at the same time unconstrained by the operating system it works in, or the presence of a network. So I think it's not enough for a programming language to make hard things possible. Hard things should be easy as well. It's not enough to be usable for a program for a developer. The end user needs to be able to use that as well. So all these things that we concentrate on, having niche server-side applications, we are diverting further and further away from a very, very useful feature that I would say it shouldn't be difficult, and it isn't difficult now. Now, there is one more thing. I want to thank you guys for listening. I'm going to finish off here now. But there is a little final giveaway this time. Yeah, I'm going to give away to one of you guys randomly these things, a Raspberry Pi Zero, yeah, WA version. It's got an integrated network function. It's got partly sorted headers. It's got an SD card, which has, amongst other things, my difficult to install GUIDeFATE module also in there. It's got adapters for HDMI and USB for other devices that you might want to. I'll also include the 16-channel pulse width modular controller board with a DIY connector for the Raspberry Pi. I'll give you 3 servos. I'll give you a cheap webcam. And the idea is this. It is yours if you want it. Yeah? You just have to email me and let me know. And one of you will get it. The reason I'm doing this is 2 reasons. One is that I want you to invent something else. I want you to invent something, and I want you to help me because I'm not a pro at this. Yeah. So my toolkits are very flawed. They're not very good code, and it is very difficult to install the backends. The reason I put this up is because to put that GUIDeFATE and all the backend code in there, which is difficult to find. It's not easy to find any reliable, consistent source for any backend apart from GTK, and GTK is sadly not consistent at least in the Perl interface, not consistent. So to put that in there is difficult. It takes a good 3 or 4 hours to do that, waiting for things to download on a little Raspberry Pi, which has got a very low backend. So you're welcome to it. It's yours. Email me. I've got it in my bag now. My email address is safetynet, SAIFTYNET @gmail.com, and one of you will get it. So thank you very much. Any questions? Or is there time? There may not be time for. Oh, yes.
What did you use for drawing inside the HTML page? Using SVG or just the HTML drawing?
So yeah, yeah, I use because.
Please repeat the question.
Okay. So the question is, what did I use to draw in the HTML pages, the little the graphics? So to draw into HTML pages, what I did was I create an SVG file, and the SVG file is converted into JPG or bitmap depending on the backend. So GTK will happily render an SVG image presented to it, but TK will want it to be converted to some kind of binary blob, and that happens at the backend. So for those drawing applications, I used that. But there are other applications. So for my GNUplot application, GNUplot generates a PNG file. So I convert that, if necessary, to a file that a format that the backend that I'm using will react with and present it. So TK will not render SVG files or some other files very well. So it has to be converted. And which is why there is a dependency on ImageMagick for that conversion for those applications. But it's not these are not code that I invented. I just cut and paste from the internet. I look for applications. If there may be much easier ways of doing these things than I know. Well, I think I'm going to give everybody a chance. I'm going to give everybody a chance to have it. As I say, the idea is that it is difficult to put any of these toolkits. And in fact, I don't know how to. I put it on CPAN, but there's an old version on CPAN. And when you try and install it from CPAN, it tries to install all these backends. And these backends will fail in many situations because the CPAN version of these backends often don't work. They often you have to go and download them yourself. So it's sometimes easier to, and I put their instructions on GitHub. but they may be different for different systems. They certainly have been for me. For each of my computers, I've had to go through a different set of things. And it would be nice for CPAN, the modules in CPAN, to be updated enough to allow this to happen more transparently, and so the best way of getting GUIDeFATE is actually to go to the GitHub page and download the little. I've created a little all-in-one package, a zip file which contains everything you need to do that. Hopefully, yeah. So yeah. And no other questions? Thank you very much.